I hope you had a few minutes to look over the basic process and noticed that most things are going to look just like ordinary fraction operations, but we have a few extra things to deal with because we're using variables. And sometimes that means we can put in numbers that make the fraction go bad. Basically, whenever the denominator equals 0. So we have 3x as a denominator, 2x as a denominator, 6x as a denominator. Is there any value for x that will make those denominators equal 0? Well, of course there is. When x equals 0, all three of them will be impossible. So we say that we are going to exclude x equals 0. We are going to leave it out of the possible input values. Sometimes they call that restricting the domain. Sometimes people just write x cannot be 0. So leaving out the fact that we can't use 0, what is the smallest common denominator? Something that 3x will divide into, 2x will divide into, 6x will divide into. I'm going to pick 6x. 3x will divide into 6x, 2x will divide into 6x, and 6x is 6x. Some of you may have learned to multiply all the denominators together to get a common denominator, and that works. But we do not want 36x to the third power as our common denominator here. We're going to use the smallest common denominator that we can. And just as we did with regular fractions, we try to make 3x turn itself into 6x, which is possible if we multiply by 2. But of course, if we multiply the denominator by 2, we have to multiply the numerator by 2 to keep it balanced. Basically, we're multiplying by the number 1. It just looks like 2 over 2. Similarly here for the 2x, to turn that into 6x, we need to multiply by 3. And we can get away with that as long as we multiply the numerator by 3. And 6x we don't have to do a darn thing to. So coming down, because I don't have enough room up there, I'm going to go ahead and do the distribution. So we'd have 10x plus 2 over the now 6x, added with 9x plus 12 over its new denominator of 6x, added with the x plus 2 that was already over the 6x. Now that we have a common denominator, we can add them all together. But we don't add the 6x's together. It's these sort of 1 over 6x, these sort of 1 over 6x, these sort of 1 over 6x. How many 6x's do we have? Back when you first learned fractions, they may have had you go to all of this trouble. That is all over 6x, which is fine. Most of us just go ahead and start combining the like terms. So it's looking like we have 19x plus another one is 20x, and 2 plus 12 plus another 2. Now maybe that will simplify. Maybe there's a common factor. Is there anything that will divide into 6x that will also divide into 20 and also divide into 16? Well, they're all even. So this could be 2 times 10x plus 8 over 2 times 3x. And then the 2's cancel out. We have 10x plus 8 over 3x. You can leave it like that. If you want to factor 2 out of the numerator, that would be fine also. Don't cancel out the x's. we can only cancel out factors, things that are being multiplied. And now we'll get to some more that are more pre-calculus speed.